your problem number 52 from your deep practice book. So we have this thing. You're given two equations up here. Look at me, I've got a new color. And then you're told that A and B are constants. We can just kind of throw that away. It just means that A and B are numbers that don't change all the freaking time. For which values of A and B of the following options does the system of equations have exactly two real solutions? All right, the first thing I'm going to do, because I'm terrible at things like this, is note that, oh, y equals 3, and then I see y again, so I'm just going to rewrite this entire equation down, only using 3 in its place. So 3 equals a times x squared plus b. Okay, wonderful. And then I'm going to start by taking some of the answer choices that give us what a and b are and just filling it in and then seeing what I had to get for x. Let's start with a, because a is the first letter in the word apple, and I love apples. So a is negative 2. I'm going to write down 3 equals negative 2x squared plus, and what is b? Oh, I see that b equals 2 plus 2. Okay, I can solve this, right? I can subtract 2 from both sides. 3 minus 2 is going to be 1 equals negative 2x squared. I can divide both sides by negative 2, you get negative 1/2 equals x squared. And then I can take the square root of both sides, joujou, and then joujou. And then I see that, oh, this is a problem. I'm going to have to take a square root of a negative number here, and I know that that means that there are no real numbers that with the square root. You can take the square root of a negative number. I'd have to start working with imaginary numbers. And since it says real solutions here as opposed to fictional solutions, then I can kind of ignore that. Okay, so choice A is not going to work. I'm going to take my trusty dandy eraser, and I wish I had a much larger eraser here. Wait, that doesn't even work at all. Wait, but maybe this would work even better than anything. No, this is just really not. But you know what? Darn it, no. Stop. Do not do this thing. Hardness radius. Wow, it's just not really working at all. Okay, well, let's just pretend that this is going really, really well. Oh, there we go. Yes, this. Oh, it's kind of almost too big. Well, we'll just trust that we can all see this. Okay, great. So let's try the second option. The first option is dead to us. We never liked you in the first place. Let's try option B. Again, rewrite this entire equation, now using the numbers from B. Negative 2 as a squared plus positive 4. Okay, I can solve for x doing this. Subtract both sides by 4, so minus 4 minus 4 if I wanted to really be good and write that out. And you know what? Why not? Let's do that. Negative 2 squared, negative 2x squared. Divide both sides by negative 2. Oh, that's nice because the negative divided by the negative, negative 1 over negative 2 really is going to equal positive 1/2. Equals x squared. I love that, because what I'm going to get if I do that is x equals either 1 over, oh, that's a weird thing, right? Well, you know what? This or the negative version of this. If you really wanted to see what this would be, and you don't need to, but if you really wanted to do that, you could say, okay, that this part right here would equal the square root of 1 over the square root of 2. Square root of 1 is what? Why, it's 1. The square root of 2 is like 1.4, and then it would go on for a really long time. This is not a pleasant number at the bottom, but it is a number. It is a real number. We don't have to get fictional and imaginary with that. And also, this is going to be wonderful too, because we're going to have the negative version of this entire thing, the negative version of square root 1 over square root 2, which is just going to be this number at the end of the day with a negative sign in front of it, and that's going to be a real number too. So B is actually our option. And you could see if you really wanted to go through these other numbers, and I mean, obviously I don't really want to go through these other numbers, but you know what? What the heck? Let's do it. I finally figured out how to use an eraser in the program My Brushes, which I think qualifies me for some special treat. I think I will have a Werther's Original at the end of this. I'm joking, of course. I haven't actually had a Werther's Originals in years. Delicious pieces of candy, though. I wish I did. I might have to go out and buy one. I'm going to choose an ever so slightly different color because I'm getting bored. Okay, and what? And in the system of equations above. Okay, so we'll just try the same darn thing, only now we will be using choice C, because why not? So 3 equals 2a 2. The a was 2. X squared plus 4. Can subtract 4 from both sides, get negative 1 equals 2x squared. I'm going to have that same sort of negative problem I'm seeing right now. X squared equals negative 1/2. Yep, same problem as we had in choice A. So then let's try choice D. Eventually I'll figure out a faster way of doing this, but it's not too terrible for right now. And I'll try 3, just rewriting the whole thing again, equals 4x squared plus 3. Now this is actually really interesting. I'm going to subtract 3 from both sides and we get 0 equals 4x squared. Divide both sides by 4. And I get 0. 0 divided by 4 equals 0 equals x squared. And actually, if you take the square root of both of those sides, you're going to get x equals 0. That's legitimate. However, they're asking for which of the following values of a and b does the system of equations have exactly 2, kind of cut off there, but the word says 2 real solutions. This has no real solutions. This had no real solutions. It had imaginary solutions. This has 2 solutions. One was positive and one was negative. And this has only one solution. That solution is the number 0, which is real, but it's not 2 different numbers. So our correct answer choice is B. How do I stop? That's right. I still haven't really figured this out. Oh, here we go.